And we see if we're live streaming. I think so.
I'm talking to.
Okay. Welcome everyone. This is the last day of the Biodiversity Data Mobilization Training in Haiti. You're all very welcome. We are live streaming this talk on YouTube, so it will be available for later if you want to revisit it. So today we are going to talk a little bit about biodiversity data quality. Can you all see my screen?
Not now.
Yes.
Now,
Okay,
yes.
that's okay. That's okay now.
Okay, let's try it again just in case. Okay, is it visible?
Yeah, perfect.
Okay, so we're going to divide this talk in two main parts, let's say. We're going to talk first about some concepts on data quality, and then we're going to mention some tools that might be useful to assess data quality and to improve it. So let's start with the concepts part. And within this part, we're also going to divide our presentation into a section about problems that we usually find in biodiversity data. And this will be to exemplify the kinds of issues that we have to be aware of when we talk about the quality of the data. Then we will explore some basic concepts and principles and some solutions that can be applied to improve the data quality. So let's start looking at some of the problems that we find out there in biodiversity data. And the question that I want to pose to all of you is, how bad are the data that are available out there? And to answer this question, I want to show you some examples, both related to some simple cases, what we can think of simple cases. On one hand, for some fields that are recommended to use controlled vocabularies or restricted values. We're going to see also some cases for geographic information. And then we're going to explore just a little bit more complex cases, and in particular, what happens with taxonomic information. I call this one a complex case because it usually requires more expert input to be able to fix this kind of problems in data quality. So let's start with some fields that pieces of information that we're recommended to use controlled vocabularies. So we have talked in previous presentation of this series, you can see them in the YouTube channel. We have talked about Darwin core terms. And among those Darwin core terms, there are some that recommend to use a controlled vocabulary. So here is the list of those terms. So for example, country here is recommended to use a controlled vocabulary. So do not just put any value for the country, choose from a particular list of valid values. That's basically what it means. So you see that there are several terms that expect or for which it would be best to use control vocabularies. Now let's explore what really happens in the data. In the data that is shared through the GBIF network, we see a lot of variations, and people not always comply with this recommendation. So let's take a look at what happens in some of these fields. The first example is for the field sex. And the numbers that are shown on the screen are the numbers of distinct values that we find in GBIF. So this means that we don't only find male and female and hermaphrodite, but we find over 20,000 different values in that field. For other fields like reproductive condition, we also see very high numbers, more than 55,000. We also have a lot for life stage, and we even have many values for country. And here I put this value 32,000 is the distinct values that we have, and the expected is corresponds really to the ISO countries, the ones that follow the ISO standard. So we're expecting a maximum of 250 values, but in the data we find 32,000. So you see that people is not really using controlled vocabularies for these fields, or alternatively and together they are using different controlled vocabularies. So let's look at one of them in detail. I chose the field sex to show you. So among the values that we find, we can see some that we can understand. And so, for example, we find female, male, gynandromorph, hermaphrodite, and then we have other values that we can guess what they are, more or less with some confidence. So if we find an F, we can guess this means female. If we find F period, it's a variation of the previous one, but we also can guess that is female. If we find U or undead, we can guess that is undetermined. So we have here many different ways in which the values are abbreviated. We also have values in different languages. And so instead of having male, we have all these variations. So different people are using different languages. Then we have other values that are doubtful, but that we can still understand as a proxy for sex, right? And then there are other values that have mixed concepts. So this means in the sex field, people is capturing, for example, male, female, juvenile, where these two are really information about sex, but this one is not really about sex, but about life stage. Also, we have, for example, gravid females, where we have mixed information about the sex and the reproductive condition. And then we find things like measurements that are not directly a sex. We can infer that if it has testes, it's a male, but it really doesn't say it. So this is actually data about measurements. And then we have other things like preparations data captured in this sex field. So you see that that variants that we find can be of very different nature, can be with different formats, in different languages, abbreviated, can be mixed with other concepts. And so to summarize a little bit what happens in these fields, that expect controlled vocabularies, not only for sex, but for all the others, is what I was mentioning just a moment ago. We have different languages, we have different formats, we have incorrect mapping. And also it happens at times that we have different words that describe the same concept, even in a single language. And also the same word can be applied to different concepts. So these are problems that are very difficult to sometimes to detect and to solve, and that have to do with language use. So what are the consequences of all these problems? Basically, that content can be excluded or incorrectly placed, and that there is great variability. And so in the end, this means that data is less discoverable and less usable because people cannot find it. And so, for example, if we're looking for males and we want to get all the records, we would have to know all the possible variations of that word to get back the records that we want. So that is really a problem here. So this is just an example. Now, for these problems, we can identify several reasons that we can divide into proximate and ultimate. And among the proximate reasons are diversity. And this means diversity of people, diversity of experience. So this diversity doesn't just have to do with the data, but rather with how people deal with it. Then there is lack of adherence to best practices. So people need to know that there are best practices and need to apply them, to use them. There is sometimes lack of understanding, can be both of the standard or of the concepts themselves. We can also identify inexact correspondence of concepts. So sometimes really the information that we want to share does not fit perfectly with the available, for example, Darwin Core terms. And then sometimes people force it into those terms when they don't really follow the definition. And then there is either absence or lack of adherence to controlled vocabularies. So sometimes we don't have controlled vocabularies available, and sometimes we have them and people don't use it. And among the ultimate reasons, we may identify there is insufficient effort, and this could be because there are no resources. There is either no funding, no money, or no human resources available to check the data, to clean it, to improve it. There is also lack of participation. So when people have questions, sometimes they are shy to ask, and then they don't get the answers, and so the data remains dirty, let's say. So that participation in the community is also an underlying reason here. And of course, there are also gaps in the documentation. So we recognize that documentation is often insufficient, and sometimes it's not attractive enough for people to look at it. It can be tedious. And so this is for all the community to think about and to work together on how we can document the standards and the best practices, to use them and so on, so that people can relate to that documentation better and can actually apply it. Now, so I mentioned here, we've seen some examples for cases that require controlled vocabularies. We're going to look a little bit at geographic information. What happens with the geographic data that is associated with the biodiversity data records. If we look at GBIF, this is data from 2 weeks ago, more or less. We see here number of occurrences on the y-axis, and down here we see the date. So the darkest violet here are records that have coordinates. The lighter color is records that have only country information without coordinates. And then there is the total. So we see that most of the records that are shared through the GBIF network have coordinates. Now, if we look into a little more detail and we split this, this graph into preserved specimens and observations, we see that there are different patterns. So on the right are the data for observations. And we see that almost all observations have coordinates. So this is good. This is excellent. Is really great. But if we go to see the preserved specimens, typically museum specimens, herbaria specimens, we see that the proportions change quite a bit. And so there is a large amount of records that don't have any coordinates, geographic coordinates. So they only have country. And so you see that the reality between observations and preserved specimens is very difficult. And we can think of many reasons for this, but probably one that we can point out is that most of the observations are coming now from citizen science projects. And so many of them are gathered through applications, for example, that we can have on our phones. And so it's easier to record the coordinates as we take as we record our observation. Instead, for the museum specimens, many times we have older specimens that were collected some time ago when capturing geographic information was not as usual or as in practice as it is nowadays. So for those data, it's difficult to complete the missing coordinates, and it requires much more work and dealing with the particular specimens at times. Now let's see some examples. This is an old slide of how it would how data from the United States would look if it wasn't cleaned up. As I said, this is not the current situation, but I think it's a good example to show. So this is data from the United States shared through the GBIF network, and we can see that the distribution of the records is worldwide. And I want to show you a couple of patterns here. The first pattern is this line. If you have not observed it, I will go back. You see that there is a clear line there that coincides with the 0 longitude meridian, the prime meridian. And so this means that in the longitude field, people is putting 0. Okay, some of those records might be really that they have longitude 0 degrees, but this is most probably due to autocomplete processes that sometimes happen in databases. So sometimes in the databases, if the field is empty, then it defaults to 0. And so that's not really the longitude for that record, but rather is a consequence of how the database is built, and is spurious. So we see that for longitude. I imagine that you know what's coming next. The same thing happens for latitude. So we have a series of points here that have 0 latitude. Again, some of those might be correct, but probably many of those are just an artifact. And then if we look in the middle of the screen, right there, there is a very red spot. It's very teeny here. And this corresponds to 0, 0. And you see that there are a lot of records. That's why it's red. So the redder is the more, the largest amount of records. So you see that there are many that have both coordinates as 0. So again, we think that many of those might be really incorrect and defaulted because of how we capture the data. So also we can see in this pattern that, please don't mind my pseudo polygons here. More or less, we know that this is the United States, and we can see a clear pattern on the other side of the globe that is kind of mirroring the United States territory. So this happens when the longitude is negated. So records appear on the other side of the world. Something similar happens for latitude, and to a lesser extent, it happens for both coordinates. So you see that there might be many problems with the coordinates fields. Sometimes they are defaulted to 0. Sometimes they have or they lack a minus sign that correctly indicates the hemisphere. And so it ends up placing the record in a location where it doesn't really from where it doesn't really come from. So I want to move a little further than that, not just looking at the coordinates, and looking now at the georeferences. So what's the difference between having a georeference and having coordinates? Having coordinates, we know we have latitude and longitude, or other formats that we can have coordinates in, like grids, or one that you might have heard of is UTM. So one thing is to have coordinates. Another thing is to have a georeference. According to the georeferencing best practices, the 3 minimum elements that a good georeference should have are coordinates, datum, geodetic datum, and uncertainty associated. So I'm not going to go into the details of georeferencing, but those are the 3 elements that we will need to actually have a georeference. And so if we look at the records in GBIF over the years, we see that many have coordinates, as we were seeing before, but the ones that are georeferenced are much less. And so if we look into it in detail, we see that we have, of occurrence records, we have 93% that have coordinates, some kind of coordinates, so we can put them on a map. But if we add the uncertainty, that percentage goes down quite a bit. So only 36% have coordinates and uncertainty associated. And then we have that the percentages keep going down if we add a datum, either whether it's not known or identifiable or not. And if we want to make an even better georeference that we can actually reproduce, adding the source, the protocol used to determine that georeference, we see that the amount of records that actually have all that information are very few. So even though many records have coordinates, few actually have georeferences, and even fewer georeferences that can be reproduced. So this is more or less to show you which kinds of problems, general kinds of problems that we find in geographic information. As we saw before, there are some shared problems between these two categories because some geographic fields also require controlled vocabularies like country code and country and continent. So we also find those kind of problems for the geographic information. And I'm going to pass now to the taxonomic data. And I'm going to show you an example from a study that was conducted some years ago, where the authors looked at names, taxonomic names for, in this case, for vertebrates, and they tried to understand if those were valid names, and if they were not, if they could find the corresponding valid names. And in the process, identify different types of issues with these names that are, on one hand, synonymy, which they did not consider an error. Synonymy is not an error. It is a problem, it is an issue, but it's not necessarily an error because it has to do with different opinions. And then there are errors like misspellings, format errors, and conceptual errors. And in these conceptual errors, we include, for example, mismappings to other Darwin core fields, putting information that shouldn't be there. And so in this study, well, this is the summary of what they did. They looked at 1,000 different names, and looking at those names, they found that they could understand what the name was referring to in the majority of the cases, but of those original values for the names, less than half were actually valid due to all these issues in here. And so, for example, they found that almost 30% of the names had problems or had issues with synonymy, and there were also incidences for misspellings, format errors, conceptual errors, and some of them had more than one of these issues together. And what was interesting about this study is that the authors tried to understand which could be the drivers for these errors. And so, for example, they looked at the collection year here. So in the y-axis, there is the probability of having a problem in the name. And in here, we see that if the record was collected more recently, then it has less probability of having errors. And they relate this to the fact that older labels, for example, in museums, are usually more difficult to interpret. And so records that were taken a long time ago might have more errors due to that interpretation. On the other hand, they related this probability of having problems with the size of the institution. So the question here was, do big museums have more problems with scientific names than smaller institutions? And the answer was that the bigger, here is bigger institution sharing more records, bigger institutions tend to have less issues than the small ones. And so this might be due to the fact that larger institutions usually often have more resources than the small ones, and so they can dedicate those resources to curate the data. And then there are two other results from this work that I want to show you. One other thing that they looked at was on whether the specimens were coming, where the names were coming from specimens that were current, let's say preserved specimens that are current from our time, or if they were fossils. And what they found was that fossils have much a higher probability of having issues than specimens that are of recent times. And this was attributed both to synonymy and to some conceptual errors, because the paleontological collections are newer to the community and to the use of the Darwin Core standard. And the last result that I want to show you here is that they also looked at the different clades that these names belong to. In this case, it was for vertebrates. So the clades that they divided the data in were amphibia, aves, fish, mammalia, and reptilia. And they found that the probability of errors, or of having issues, really, not errors, issues, is higher for certain clades. And that is explained by synonymy. And so certain clades in here, particularly amphibia, but also reptilia, show higher rates of taxonomic revision. So in the data, we find synonyms more often for those taxonomic groups. So these are some of the problems that we find with taxonomic data. And you see that to solve some of this, specifically for synonymy, we need expert knowledge. So it's not just changing a format. And one conclusion that this study had was about the effort required to clean these taxonomic fields. So basically, to the authors, it took more or less 4 hours to review 100 names. And so this means that this data was taken from the Burnett portal. If we wanted to clean this portal for taxonomic names, only this portal, we're not talking about all of GBIF, we're only talking about this portal, it would take 10 years to do it manually. So you see that this is crazy, really. And so that is also for content that we already have digitized. Now think that this information is usually coming from museums, and so if we really wanted to clean the original information, we would have to go back to each label. So imagine the amount of time that would take. And imagine that the amount of time that it would take. At this point in time, I think Burnett had around 20 million records. GBIF has over 1 billion now. So imagine this multiplied if we had to do it manually. So it's really impossible to do it manually. It's undoable. But so that you have an idea of what it takes to do this kind of work. So with that, I close this part about the examples of how bad are the available biodiversity data. And I would like to summarize some of the problems that we've seen while reviewing these examples. So the list here includes problems such as redundancy. We don't use standards, we have synonyms. We have missing values when the values are not present. We saw an example for the coordinates. We have incorrect values when the values do not represent really the facts. Non-atomized values when there is more than one in an atomized field. One that, well, these names here are are taken from Antonio Saraiva's slide. And I love this one about schizophrenia. So this means that the field is used incorrectly. So for a particular field, we put information that has absolutely nothing to do with that field. Duplicated records is also a problem, which I haven't shown an example of, but it's important to mention. There are inconsistent values, and there is contamination, which I haven't mentioned yet, but it's also an important concept. And that means, for example, when we try to improve data based on original data that is already wrong. So what we do is propagate and even augment the problem. And so here are some examples of each one. So for redundancy, this is the capital of Argentina, which we call indistinctly either Capital Federal or Ciudad Autónoma de Buenos Aires, where this one is really the official name, but you can find it in the databases as any of the two. For missing value, as I was saying, missing latitude or longitude. For incorrect values, here we have an example of a misspelling, like this one with double L should be with only one L. This is a scarab species, or genus rather. For the non-atomized value, we see here that we have two different administrative divisions that should be in separate fields. Then we have the example for schizophrenia, where we are putting a life stage in the sex field. We have duplicated records, as I said, two identical records, inconsistent values, and here the example is this species never happens in this country. So if we have a record that has these two, this is inconsistent. And the example for contamination, for instance, completing the higher geography, the country, the continent, when we're doing that from a lower level that is already incorrect. So we have seen problems. So let's go to take a look at some basics about data quality. So two mandatory, I would say, readings are these two books by Arthur Chapman. One is Principles of Data Quality, and the other one is Principles and Methods of Data Cleaning. It's very important for someone dealing with data quality to read these materials. They have very valuable information that can guide you in the process of assessing and improving the data quality from the moment that we collect the data to when we use it after publication. So these are two works that I absolutely recommend to read. So remember that we had asked before, how bad are the data? Well, the question to this depends on how data are evaluated. So we can evaluate the data based on its completeness, its accuracy, its coherence, but it also depends on what we want to use the data for. What is the intended use? And here is when we get to the concept of fitness for use or fitness for purpose. And so if we wanted to define what is data quality, we would have to think that data are of low quality if we cannot use it. And we have to consider that we cannot assess the data quality independent of the users and the uses. So putting this into in some other words, if we only have information about the country, where a specimen is coming from. That might not be useful if we want to perform a study at a lower scale, at a subnational level. However, that record is still good to make a checklist of the species in a country. So you see that a particular record will be useful for some purposes and maybe not for others, depending on its quality. But it doesn't mean that records are useless. They are never useless. You can always use it for something. The important thing is that the more complete and the more accurate that we can make the records is the more uses that we can apply them or use them for. So this concept of fitness for use or fitness for purposes is important. So that fitness depends on some characteristics of the data. The data should be accessible. They should be accurate, timely, complete, consistent, relevant, comprehensive, detailed, easy to read, and easy to interpret. So ideally, if we comply with all these characteristics, we would be improving the quality of those data, and those data could be used for more purposes. Now we can assess the data quality on different dimensions. I mentioned some of this before. We have the completeness dimension, the consistency, and we also have accuracy and precision. There is a difference between those two. Precision is how much detail, to say it in, if we think of numerical fields, is how many decimal places we have, to give an example. And accurate means that it's actually reflecting the real facts, no? The facts, the real values. And then there is another dimension that is credibility. And this one is important because people need to trust the data. And so we will see in a couple of slides that part of that trust comes from openly declaring all the processes that we apply to the data and providing that documentation openly. So having seen some of those basics, let me mention some principles. So in Chapman's publication, there are a series of principles and recommendations on data quality that have to do with these topics here. First, there is planning. It is very important to plan every step in the biodiversity data workflow or lifetime. So from the collection point to the use step, it's important to have organization. It's important to prevent errors. So, and here, what we have to highlight is that it's always better to prevent than to cure. And so it's easier if we try to get the data, collect the data correctly, than to try to correct it later when it's already digitized or already shared, already used, maybe. So as we move on the data workflow, it becomes more difficult and more expensive as well to clean data. So prevention of errors as soon as we can in the collection process is the best that we can do. There are also principles about responsibility. People have to take responsibility at the different stages, from the collectors, the curators, the publishers, the users. It's also important to establish partnerships We have to prioritize when we talk about data quality, what we're going to deal with, how we're going to approach it. We have to think of having performance measures to understand if our processes for data quality assessment and cleaning are performing as we hope. Try to optimize the processes of assessment and an improvement of data quality. Try to implement feedback mechanisms. When people use the data, then they may detect problems that we don't see. So it's important that we allow them or we provide them a means to share those comments about the data. It's also fundamental that we train every stakeholder, from the people that go to the field to collect new data, the people that is digitizing, the people that is georeferencing, those that are sharing the data through aggregators, and also the users. And then there is transparency and documentation, which I mentioned a little bit before. This has to do with trust, and we have to be as transparent as we can and explain exactly what we have done with the data so that others can understand and can decide if they want to use or not the data for a particular purpose. And so it's super important that we document how the data was collected, if the data was assessed by any process, if we made any changes to it. So all that should be documented, and that documentation should be accessible to everyone. So these are basically the topics where we can apply data quality principles. And so let's take some summary ideas from here. So the first one is an observation. We cannot go back in time. And this means that the potential will never be as high as at the origin. For instance, if we go to the field to collect data and we forget to write down some information, that information is lost. We cannot go back, because if we go back, it's going to be different. So we're missing a piece there. So it will be very important to capture as much as possible, as unequivocally as possible. Another observation: the lack of knowledge can result in errors. And so to overcome this, we have to try to train the people, the personnel that both collects and manipulates the data at every level of the data workflow. One more comment. Any data transformation can result in a loss of information. So for example, if we transform a coordinate and we don't keep the original, and maybe we made a mistake when we were transforming it to some other format, then we completely lost the original information and it's gone. So there are two things to consider here. First, always, but always keep the original data. And the second one is always document all the changes that were made to the data. And finally, here, as I was mentioning before, when people use the data, that constitutes a quality control, because they might notice errors or problems that we have not noticed before. And so one thing that we have to ensure is that the data and the documentation are accessible. And another thing is that we have to try to provide some mechanism for people to give us feedback on our data. So these are important concepts that I want you to get out of this talk. So now that we've talked about principles, let's go to briefly take a look at some solutions. These are not all, of course, I'm just giving examples. But we can think of solutions that can be approached in 3 different ways. One is prevention, which is probably the best option that we have. If we can prevent errors from happening, that would be the best. Then there is another approach that is detect errors and correct them. This is not always possible. Sometimes we can detect them, but we don't have the resources or the knowledge to correct them. So then there is another approach that is detection and recommendation. So we note the error, we see it, and we recommend the solution, but without actually applying it ourselves. This typically happens when we see errors in someone else's data. We detect the error and we recommend them some change. And so all these solutions, all these approaches can act at all the steps in the data workflow, from the collection through the management and publication and up to the use of the data. So I'm going to give you an example of this approach of detection and recommendation, and is the use of data quality flags. Flags are marks or annotations that we associated with a record, and they're indicating that there is some kind of problem, or they are warning us about, hey, be careful because I think this record might have a problem. And so these data quality flags are usually contributed by aggregators, for instance, by GBIF. GBIF provides flags and issues. And in some systems, they are also provided by users, typically in feedback mechanisms. So if a user detects a problem, they can send feedback, and that raises a flag. So to give you an example of the GBIF issues and flags, this is the list of issues that GBIF works with. So they look at the data and they determine if the data have any of these possible issues. For example, 0 coordinates, coordinates invalid, country invalid. Here is an interesting one, depth unlikely. So this means that you have some depth information and it doesn't sound right. That there are, for example, no matching institutions to the name provided. So you see that the list is very long, and you can visit these issues and flags at this URL here. So but GBIF does a really great work in detecting problems in the data and putting flags to them. So how do these flags look? In the GBIF portal, we're looking here at a particular record from Haiti. And we see here that GBIF for this record lists the issues that are associated that they could detect. And they could detect that these issues here, country invalid, they detected that the country is derived from the coordinates and that there is no matching collection and so on. So I will show you a detail of this. And so, for example, if we look at that record in detail, we see here that for the country, the original value that the provider gave was HA. And that's really not a valid country value. It should be Haiti. And so GBIF flags this record as having an incorrect country value. And so the same, it does also derive the name of the country from the coordinates, and so it notes here, although the coordinates have no problems, it notes here that they use them to derive the country. So you can see all the flags that the record has. In this case, for the location terms. And also here, let me go back. You see that there are different terms. There is the remarks, and there is two columns. One is interpreted, and one is original. So original is the original data that was provided. So the provider published this data. And this is the interpretation that GBIF does based on the original data. And so GBIF does a series of different interpretations that some of them apply to location information, like coordinates, the datum, the vertical position, and for geography, the country in particular. They do interpret the taxonomy as well, the scientific name and the type. They also interpret identification and recording dates, and some other information like basis of records, sex, establishment means, life stage, and media type. So what GBIF does is look at the original data, and through a processing workflow, they provide interpretations based on that original. And so to give you another example from that same record, we have here the date information. And so we see in the original that this is the value that was provided. And we see here all the interpreted values that GBIF gives. And so, for example, for this one down here, for the event day, GBIF tells us that they have modified it. They have turned this into this other ISO format, which includes time. And for the other fields, day, month, and year, what they have done is derive it or infer it from the original. So from this one, we can see that the year is 1987, so they inferred this value, and they inferred the month, and they inferred the year. So they're telling us what they have done. Now, something very important is that the original data is never lost. It's always available. So we can see both the original and the GBIF interpretation. So we have looked at some of the approaches for solutions, and I've shown you some data flags there, examples. For cleaning biodiversity data, there are many possible workflows and many possible tools. And so that's what I'm going to go through now, some tools that are available here. And I want you to keep in mind that these are just examples and that there might be other tools that you may want to use. So I'm going to divide this presentation of tools into tools that perform only one function and tools that perform several functions at a time, multi-function. So for the single function, I'm going to show examples for cleaning formats and cleaning geography and taxonomy. And for multifunction, we will see a couple of examples that do all of this and more. So what are the advantages and disadvantages of choosing tools that perform one function or more than one? Well, if we use single function, we are going to be slower and less efficient. Each thing that we want to change, we will have to use a different tool. However, the advantage of using single function tools is that we have more control on each specific step. So we can control each one separately and understand very well what each tool does separately and make sure we're doing it right. For the multifunction ones, instead, these are much faster usually and much more efficient, but they do require that we're very careful with the controls and that we really know what we are doing. Because when we use multifunction, we might be changing things that we didn't want to change in the process of cleaning. So many times using multifunction requires a little more experience or more, it has a steeper learning curve. So I'm going to give examples of single function tools for changing formats. If we're talking about, for example, encoding, there are different tools that we can choose to change encoding. Some are for Windows, some are for Unix or for Mac. We have to choose the one that would work for us. These are good options. Also talking about format and in particular to parse scientific names. GBIF has a tool that is called Name Parser that allows us to separate scientific names in different columns. So that's why I call this a format tool, because it's just about the format and not necessarily the content or the meaning of the content. And so basically we provide in here scientific names, and what the tool does is separate these names into each of its species. So for example, here, this name, Abies alba, it parses it into one piece that is Abies, that is the genus or above, a specific epithet and authorship, and it continues, this one continues out here. It also gives canonical names and name with marker and so on and so forth. So let's take another example. This one here has the name and the author, and so it separates the genus, the specific epithet, the author. And so we can put as an input a series of names that we don't have parsed and have the tool give us separate different fields that we might want to share, like genus, a specific epithet, and authorship, and so on. So this one helps us to divide that field into several fields. Another tool for parsing, in this case, is for parsing dates. And so this is the Canadensis date parsing tool. And what allows us to do is we give it original dates in some allowed formats, and it separates that and gives us the year, the month, the day, each in a separate field, and it puts the date in ISO format. And so if we had this kind of input in our original data, we could transform it to the ISO and have this field separated very easily. So here on the right, if you go to this web page, you will see which are the formats that the input can have. And so that makes this makes our lives easier. It's much it's much easier to deal with dates in this way. Another tool that Canadensis provides is for parsing coordinates, which is the rationale is similar to the dates one. So we provide original coordinates in, for example, a format that is degrees, minutes, seconds, and it gives back the values for decimal latitude and decimal longitude. So not only it divides it in latitude and longitude, but also does the conversion into decimal degrees. So this one is also a very useful tool. And then for geography, I put here a series of documents because among tools, we have to consider not only programs or applications, but also documentation that can help us. And so we will see these documents here, and I list down in the slide some tools. I will go mention some of them in detail, more or less. I want to mention to you that in here I put DivaGIS and QGIS. These are GIS programs, GIS software, where I'm not going to talk about them, but there is plenty of information on the internet to learn how to use these tools. They're usually for maybe more sophisticated cases than we usually have with our data, but please keep in mind that they exist. They are very good, and you can find documentation about them openly on the internet. So about the documents, there are 3 newly released documents that GBIF has published. One is the georeferencing best practices, which I highly recommend. It has a lot of information about the georeference process and how to perform it. Then there is the georeferencing quick reference guide, which gives more like recipes on how to georeference different kinds of locations or locality strings. And then there is the georeferencing calculator manual, which is manual, as its name suggests, on how to use a georeferencing calculator, which I'm going to show in a moment. This is the georeferencing calculator. It's a program that allows us to determine a georeference. I mentioned before that the minimal elements are for a good georeference are coordinates, uncertainty, and data. And so this calculator allows us to get a georeference specifying certain parameters from the original data. So I invite you to take a look at this tool and to take a look at the manual. If you have any questions, of course, send them to the authors. They are very open to answer questions about these applications. So another tool for georeferencing is Geolocate. Geolocate as well allows to look for georeferences given a locality string, and has the option for batch georeferencing, which means georeferencing many records at a time. So I also invite you to take a look at Geolocate and the functions that it provides, the possibilities that of dealing with the geographic data with this program. There are other resources that we can use also for geography. This does not provide, this one species link InfoXY does not provide a georeference in the sense that it doesn't provide uncertainty and datum, but it does provide administrative divisions, which is very interesting. So if we provide coordinates here, longitude and latitude, this application will look for those coordinates and give us back the administrative divisions in which that point is. So if we wanted to complete the geographic fields, the geographic information, we could, for example, use this tool to get those values. Okay, that was some examples of tools that we can use to assess and improve geographic and georeferencing information. Now, about taxonomy, I want to show you a couple of resources. These two are taxonomies that we can consult, and these are really more tool-like resource. So let me go to the first one. You might have heard of the Catalog of Life. Catalog of Life is an authoritative list of species that are all over the world that one can consult. So it's a catalog. So one can go into the catalog and check for species, and we will have information about where in the hierarchy they are, and synonymy, and all that kind of information related with scientific names. So this is a resource that you can visit and you can have in your in mind when you work with biodiversity data. And another one that I want to show here is in particular the GBIF backbone taxonomy. This is the taxonomy that GBIF uses when we publish data through the GBIF network. So GBIF basically compares the names that we have in the data against this taxonomy and provides interpreted values in accordance. So it checks if our names are in the backbone or not, if they belong in the same hierarchies, and they provide the corresponding name according to this backbone. So you can visit, this is a data set actually, this backbone, and you can look at it. And this is more or less, or this is the summary of what this backbone looks like with respect to accepted species. We have this graph, and we see that most of the accepted species names belong to or refer to arthropods. And then we have a large proportion for plants, and then for fungi. And so that you have an idea of what this, how different taxa are represented within this taxonomy. So I invite you to look at this backbone, go to the data set, explore it a little bit, because this is the one that GBIF will be using when dealing with the data that you may publish. Moving on to some tools, I want to mention here the Taxonomic Name Resolution Service. This service allows us to check scientific names or lists of scientific names against the service, and to get back whether that name is accepted or not, and which is the correct accepted name if the one given is incorrect, which are synonyms, and what is the source of that information, the authoritative source. This resource is particularly useful for plants, is using these sources here, Tropical, CFL, and the USDA database. So particularly important for plants if you want to check your names, your scientific names. Another resource that is group specific is the World Register of Marine Species database, where one can also search for names and get back the information about whether those names are accepted, whether there are synonyms, what are the problems associated with those names, and so on. So these are specifically for marine taxa. And then there is one last tool that I want to show is the global names resolver. So this global names resolver is useful for any name in any group, in any clade. And so it allows us to provide, we provide it with scientific names, and the global names resolver looks for that name in different sources and gives us back all the possible results in all those sources. So here I provided, for example, two names. One is a dipteron, and another one is a puma. And so when I go look for the results, for example, for the dipteron, for the fly, I get all these results. And you see that each one is coming from a different source. So Global Names Resolver provides us with all the possibilities. So this one is coming from UBio, this one is coming from Catalog of Life, and so on. And the same happens for the other name. This one has a matching Encyclopedia of Life, and for NLBIF, there is the GB for Netherlands, and from the Index of Organism Names, and so on and so forth. So the beauty of this tool is that we don't have a single result, but rather that we can choose which source we trust the most. So for example, in the previous slide, if I trust more, suppose, the Catalog of Life more than the others, I can keep this one and discard the rest, but I can still see them if I wanted to. And another good good thing about the Global Names Resolver is that, going back, you have here, it has an API, which means that one can talk, let's say, or communicate with the server with the service from other applications. And so, for example, for those who are familiar with the use of OpenRefine, we can call the Global Names Resolver from OpenRefine and get all these results sorted out, calling the service. So we have seen there some single function tools for different things, for format, geography, taxonomy. We're going to take a quick look at some multifunction, and I'm going to mention four resources here, four tools. One is the Verdant Migrator Toolkit, then the Curator Workflows, the GBIF Data Validator, and OpenRefine. So the first one, the Verdant Migrator Toolkit, it's a toolkit that allows us to clean different kinds of data. It's a tool that is based on Microsoft Access. And I'll show you here the list of some of the capacities that it has. So with the migrator, we can map to Darwin Core. We can correct format errors. It does have functions for processing dates. We can standardize different fields like sex or preparations. It also has the processing of geographic coordinates and cleaning of higher geography fields, and some taxonomic cleaning up to the level of genus. Now, the disadvantage, so it does a lot of things, the migrator. The disadvantage is that it requires that we know how to work with Microsoft Access. If you wanted to use this tool, you can contact the Vernet team, and they could help you with using the migrator. So another tool is the project, the Curator project. The Curator project has a series of actors available, and these actors are pieces of process that do particular things. For example, there is an actor here there is a Darwinizer. That means that turns fields into Darwin core. There is another one that validates georeferences. There is another one that aggregates data. And so the beauty of Curator is that one can choose different actors. There are more, not shown here. And one can build one's own workflow, putting those actors in the order that one seems that seems to be best for our purposes. And so we can build our workflows for data cleaning and data processing, ordering and connecting these actors one after the other. Also, again, if you have questions about this one, you can always contact the developers and the project partners for Curator. And another one that I want to show you that you might use quite a bit is the GBIF data validator. So the data validator, what allows us to do is, if we have our data set ready and we go on to test if it has problems that would be detected by GBIF later, what we do is upload it to this tool, and this tool is going to show us all the problems, the same problems that it would show us if we had already published it. So basically, we select our data set to test, and you see what the program does is it tells us all the issues that it finds in our data set prior to publication. So you see it's the same that I was showing before for the flags that GBIF shows on the portal, but only that we have not published it yet. So it's a good step to take just before publishing, to put the data set through the data validator and check which are the issues that GBIF finds before we actually publish the data set. And so in here are, as I was saying, some of the flags, and it also provides statistics on your data set. So for example, sorry, here we see that only 0.02% of our records in the dataset that I uploaded have decimal latitude. So when we see this, we may think, hey, we could try to check the coordinates and see if we can provide decimal latitude. Instead, it says that every record in my dataset has kingdom information. And so it gives us an idea of what our data look like. And also for the flags, it tells us how many records have problems of each type. So for example, here it's telling me I have 13 records where the country is invalid, and I can look at that. So this is an interesting tool to assess, to pre-assess the quality of our data before publishing it through the GBIF network. And this is the last tool that I want to show today, or that I want to mention, and that is a super powerful tool for assessing and cleaning data. So OpenRefine allows us both to visualize and clean data, and also allows us to transform and augment. Augment in the sense of we can incorporate new pieces of information by, for example, having OpenRefine communicate, call other services that are available in the community. I mentioned before that we could use the global names resolver, for example, to add information, and we actually can do that through OpenRefine. So OpenRefine is free and is open source. It is developed by the community and maintained by the community. There is a very active community around OpenRefine, and they are very they're very nice. Every time we ask questions, they are always answering. So I invite you to take a look at the different forums that are about OpenRefine to understand how this community works. Some technical things that I'll go through quick. It can be used in any of these three operating systems, Windows, Linux, and Mac. It does require Java, and it is executed in a browser, but it does not really need internet to work, except if we're communicating with other services. But for most of the normal things, common things, functions that we might perform with this program, we do not need internet connection. And that is also very powerful because we can work under no connection circumstances. So it does allow to work with different types of files. It's very versatile. The general use of the program is easy, I would say. Although you have to know that to use the advanced functions, you need to practice. You need to sit down and work with the program and read some tutorials. But it's doable. Everyone can learn. But you have to know that there is that learning curve. It's a program that works on cells, rows, and columns, and that it allows us to do mass addition or transformation of the records. And that's probably the beauty of this tool, that we can make changes in many records at a time and not have to do it manually one by one. So it's very efficient. One very important point is that the original data is never affected by the cleaning processes. So the original files that contain our data are untouched. We always work on projects on OpenRefine. And it also has an advantage that we can extract all the different steps that we perform in our data cleaning process. And that's good, because if we extract them, we can directly apply them later without having to do each one at a time again. So that's another advantage, another thing that makes it much more efficient. And as I mentioned before, it also allows interacting with other services to get more information that we can connect to our data records. So these are some examples of the things that we can do in the three categories that I was mentioning before for tools. There are for format, for taxonomy, and for geography. So I'm not going to mention each one. You can have them, read them on the slide. There are many possibilities to clean data with this program. There are also good guides on how to use it. There has been recently released an OpenRefine use guide published by GBIF. That guide is in Spanish, but we're in the process of getting translations to other languages. So hopefully it will soon be available in English and French, and we'll see what we can do to have it in as many languages as we can. But otherwise, OpenRefine has very good documentation. I invite you to go to their webpage. It's really good. It's clear, and as I commented before, there is a community around OpenRefine that is always willing to answer questions. So I invite you to visit the website and the community sites. So with that, we have seen some examples of single function and multifunction tools. As I mentioned before, there are many others that you may want to use. And the question here is, how do we choose which tool to use? And I have to say that choice depends both on the objectives and the needs that you have, and also on the capacities that you have. So it's important to know that you don't need a super sophisticated tool to do some data cleaning. So if you know very well how to use a particular tool, you don't have to go to a super other tool just because. Sometimes it's most efficient to work with the tools that you know really well, because that also avoids making mistakes and propagating errors. So here, of course, there are some tools that need training, and you should consider training yourself and your colleagues in your institutions in the use of some of these tools, because it's worth it. But well, you always have to consider both things: objectives, needs, and on the other hand, capacities. So my recommendation would be, first, evaluate the quality of the data that you have. And so, for example, one way would be to use the data validator from GBIF to have a general idea which are the errors or flags that GBIF at least sees in the data. And then based on that, based on looking at the data and identifying which are the problems, then choose your tools and choose to be the most efficient possible, but knowing what you're doing. Efficiency without knowledge is useless and can cause more trouble than the solutions is providing. So it's always important to know what the tools do. So after this recommendation, I invite you to look at the GBIF website. They have a section where they list many tools that one can look at. Here, you will see that in here, for example, in the list, the georeferencing calculator is one of the tools that is listed, but there are many tools that you can navigate and see if any of those would help you to accomplish what you want to do with respect to data quality, both assessment, improvement. And well, in this page, you will find tools and resources that might be useful to you. So with that, we have seen both concepts and some examples of tools. And I want to reinforce and repeat once again that there is a big community that can help you with data quality and with biodiversity data publishing in general. So don't be shy and reach out to the community, ask your questions, ask the people that have already worked with this before and that can probably recommend you how to approach the data quality assessment, how to prioritize it, the resources that you will need. For example, if you're going to improve the quality by doing georeferencing, well, that needs some careful planning, and there's a lot of people who has done it before that can help you. And about the tools, of course, the specific community for each tool, or the general community who might have good insights to share with you. So with this, I'm finishing the data quality presentation. I thank you all for your attention, and I'm open to questions. Thank you.
Thank you so much, Paula. So we are all here, and I'm gonna ask people if they have questions. So
Kali
Carly is there. Carly, good morning. Are you there?
Good morning. Yes, I'm here.
Okay. How are you?
I'm good. Thanks.
Okay.
Thank you, Paula, for that presentation.
Yeah.
Oh, you're welcome. Hi, Carly.
Hi.
questions. I'm waiting for the questions.
Okay, so I see here that Annabella is letting us know that there are questions on YouTube.
Okay.
So one of them, I'm going to read here from the chat. Thanks, Annabella, for keeping an eye on the YouTube. So one of the questions says, talking about the credibility of the data, which are the elements that that warrant this credibility? Well, we can think of many things that are related with credibility. So one thing is to be open and to share the documentation that is related to, associated with the records. So credibility comes from both, how could I put it, transparency and experience. Sadly, that's the case. That's also the case. We usually tend to believe long-standing institutions as a default, by default. So that is a reality that doesn't have to be, that we should try to modify. And the way to modify it is for everyone to be open and transparent, and to make sure that they provide all details about the data and about the processes and about the people involved, so that anyone else in the world can see who participates, how the processes are performed, so that they can either repeat them or assess them or change them or whatever. So the more transparent we are and the more data and metadata about how things are done we provide, that adds to our credibility. So for example, if we have data that we don't know where it's coming from, if it's in an institution or not, or who curated it, or how it was georeferenced, we cannot really trust it pretty much. So I don't know if Diogen, you want to add something or ask further about that one. Marie, can you check in the room if this answers the question?
Mr. Teojan is online. He's one of our participants, but he is online right now. So we can just ask him. He can just let us know by a chat if you really understand the answer. Mr. Teojan, I know you are here. So if you understand, can you please let us know? I have one question while he's not answering yet.
Yes, please.
Okay. So how does GBIF make sure that the data that some institutions or country are sharing are clean?
Well, that's a very difficult question, because again, clean is somewhat a subjective concept. Data will never be perfect, probably. I know we aim at that, but it will never be perfect. So all that GBIF can do is to check for some characteristics and see if those characteristics are met or not. So for example, they can look at the coordinates and check if those coordinates are valid or not. So in that sense, they can give you a flag and tell you, well, hey, the coordinates here seem to be wrong. you should check them. And so they have a lot of fields and of characteristics that they check, but there is no way to check absolutely everything. There is no way, at least right now, and for the near future. It's a matter of probably iterations and several steps at the same time of data quality assessment. So for example, GBIF can look, or any aggregator could look at format issues and at the names, but so far GBIF does not check, for example, if a given species is expected to happen in a given place. So that's something, for instance, that has to do with consistency. I think I gave an example today in the presentation that was, I believe it was a lemur species that was recorded in Haiti, in my example, no? And so lemurs don't happen in Haiti. And so that's an inconsistency that GBIF doesn't check. GBIF may check that the name is correct and that the geography is correct, but right now it's not crossing the distributions. So it cannot tell you about those kinds of errors so far. So they will let you know the errors that they find so that you correct them. They will not force you to correct them. Actually, they will provide an interpretation, as I showed today, but that doesn't mean that you absolutely have to fix it in your database. It means that there are issues.
Okay, thank you so much, Paula.
Comment les capables d'aider nous pour que nous utiliser méthode cleaning, par exemple, OpenRefine.
Okay, are you there? Another question that we have?
Yes, please.
Okay, so someone is asking here that how can you help us about the cleaning process for the OpenRefine?
Well, if you want help with OpenRefine, what we should really do is organize another workshop, and specifically to learn about OpenRefine. We have given some workshops about it, and so I think it is a possibility to organize an event like that. So we should talk about that further if there are people interested. And otherwise, if we're not thinking of a workshop, of course, if you read the guides and you have questions, you can always either ask the community or ask me. You can send me an email and with your questions, with your comments, your doubts, so those are the two ways in which I could help, either offering a workshop or by individual consultation.
Okay. Okay, thank you so much. Mm-hmm.
Workshop li pase ki nesesèr ke ta open DeFi, pilot barè li pase ki nesesèr kon workshop an.
So what, we have another question. So what other workshop do you think it's necessary to do exactly?
Sorry, can you repeat, Marie? Because I didn't hear it very well.
Talking about workshops. So what are some other workshops do you think we should plan on doing?
Well, a workshop
Like related
particularly,
database.
Well, there are two or three things that you could think of for the future, I believe, or four. I keep adding ideas. So about data quality, you could have a workshop to learn, as we mentioned just before, to learn how to use certain tools, could be OpenRefine or OpenRefine and others. So that for data quality. I do think that georeferencing workshop is always a good idea to learn how to georeference records. Another good workshop that I would think about is a workshop about data use. And so there is very good material from GBIF about that, on how to mainstream biodiversity data into policy. That's a very important piece that doesn't have to do directly with the with the data or with the data cleaning or the data quality, but of course indirectly it does, and it's a very important piece of the puzzle when one is dealing with ministries and trying to influence policy and decision making, so that we can help to implement actually good conservation actions. So those are three that I can think of right away. Another one could be about how to build a database, but that's I wouldn't think about that one as a workshop, really, because all that you can do is show different options, but ultimately for deciding on a database, you have to take into account your own reality and your own needs and capacities. So a workshop will probably not help you with that. It would probably help more to have one-to-one or small group conversations, maybe meetings, to talk about different options for databases and understand the technical requirements and all that. So for that one, I probably would not suggest a workshop.
Okay.
Annabella, I don't know, maybe you have some other ideas about this.
Well, actually, depend of the data and the person which path is going to take. But I understand that the OpenRefine is a really nice tool. You must to learn to use it, but after that is really easy to use. It's not really difficult, and there are a lot of guides how to do it. Also, I want to point about the e-learning courses that GBIF is offering that I mentioned on the first day. That one was the next steps in known management, another of biodiversity data mobilization and the data used for decision making. They are all available through the GBIF Spain e-learning platform. But I don't know, we are open to offer help with any question or just working with the files is not an issue. And any other workshop that we can offer, we can just send the information to all of you. But for the moment, I think that Paula, you already covered all. Thank you.
Thanks, Annabella. And thanks for pointing the e-learning to the e-learning.
Okay, so thank you so much, Annabella and Paula. So thank you, Carly. So do you have any advice for us according to the workshop or database planning?
Well, my suggestion would be that we all gather our impressions about this whole workshop and maybe meet again briefly, maybe in a week, when we have a clear idea of how the workshop went and the impressions from the participants, and what would they be willing to do, which are their needs, which are the data that they have that they would like to share. And so based on that as whole full assessment of the workshop, maybe we can plan either further activities or mentoring or whatever you need. Does that sound reasonable?
Sure.
Yes, sure. Sounds good. Annabella, do you have anything, or Carly?
No, I just want to point about another question on YouTube is what do you think about a workshop on QGIS or RGIS?
Well, I think it would be really good to have one. It's always super useful. It's probably not needed for sharing biodiversity data plainly. However, for some other uses, it might be super important to have that GIS training. So again, it would depend on the needs of the publishers and users in the country, whether that workshop would be a priority or not. It's always good to have one. But well, it depends on the reality of your place. I don't know, Anna, if you have any other opinion about that.
No, it's really useful. You're right, Paula, but I just want to point that if you want to publish your data, you can do it in different steps. And maybe on the beginning, if you really want to share the data, you can share it without all the georeference part, and then you can work on that and resolve and publish that part. You can complete the data later. You just must to be aware that if you don't have your data with decimal longitude and latitude, the point is not going to be showing on the map, but the data is going to be on the portal. And that depends really about the reality of the different institutions. So there are many ways to work. There are no only one solution. And I believe the most healthy way is to find the velocity and the way that each collection, each institution can work and start just going on that path.
Okay, thank you so much. We want to thank you since we are heading to the end of the presentation. So we are very thankful for all your efforts that Annabella, Paula, you've been with us since the beginning, like about 5 weeks that we've been preparing this presentation, and you've done everything to just make this possible. So Mr. William and I, we really thank you, the participants, we really thank you. And I think I'm gonna let one of them to say something, and Mr. William also will have to say something. Thank you so much, Annabella, Paula, and thank you, Carly, for being part of this. This is really important. Thank you.
Qui est-ce qui a dit un bagay? À beaucoup d'eau, est-ce que du dernier mot pour vous? Moi, naturellement, c'est merci parce que vous mettez disponible depuis lundi pour observer nous. Et servez nous bien. Nous avons des pouvoirs là que servez nous bien. L'irrité mon côté par nous pour nous mettre en pratique. Et vraiment nous apprécier l'amour et la capacité que vous mettez pour servir nous pendant toute semaine.
Okay, so we have Mr. Kudo. He's the director of ANAP, and he said that he really thanks you a lot for the presentation and for all your service through this workshop. And he said that he will, like, the things that they have to do right now is to use that learning and, you know, practice them in order to do better. What else? You want to say something?
Thank you very much.
Mr. William?
Paula and Annabella, Kali, thank you very much for your time. I see your passion to do this workshop. I think we will work and try to make what you teach us and practice. And I do remember since 2017, we are in this process and today we didn't publish, but now it's the time, and we hope in your mentorship to help us to publish. Thank you very much. And we are very happy that you have time to share all that information with us.
Thank you, William, very much. I will now stop the live streaming. Thanks everyone who watched on YouTube. Hope you enjoyed it and it was useful. So